Let's take a moment to formally introduce the components required for secure network access. On the left-hand side, we have our supplicants. Could be a laptop or desktop. It could be Windows, Linux, OS X for mobile devices. Could be iPhone, could be Android. And when these devices connect, they basically reach an authenticator or network access device. This is what I was saying could be a firewall, could be wireless LAN controller or access point. It could be a switch. In any of these scenarios, the issue is really the same. You've got a user on the outside that says, hey, let me in. Now, when they're trying to authenticate, they're logging into the ASA or they're logging into the switch, not to log into the ASA. They're not trying to get to a shell or terminal and type Cisco commands. They just want to log into the network. So their destination is not to, but through. It's an important distinction. When things are going through the device, it tends to be radius that's leveraged on the back end. When things are going to the device, when it's administrative access, it tends to be TACX+. It doesn't always have to be, but these are the trends. Again, the authenticator's job is to make sure that this is a valid user. So when someone comes in, we say you're not allowed to go anywhere without completing an EAP login request. So the user will encode their credentials using extensible authentication protocol. When that gets to the switch doesn't think about it. He goes, I don't know what your user account is. I'm just going to relay it to an authentication server. So that EAP message actually becomes payload. And it rides on top of radius, which rides on top of UDP, which rides on top of IP, which rides on top of Ethernet. So that's our protocol stack. Main thing I'm trying to illustrate for you is the fact that this EAP message isn't so much processed or validated by the authenticator. It's more handed off. And when it's handed off, it just becomes payload for radius. Radius is going to be passed to that authentication server. The authentication server is going to push data back to the authenticator. Again, a lot of times the way that works is the authentication request comes in, and what comes back is authorization. It's like, hey, we've got a username of this and a password of that. And the AAA server says, that's fantastic. Not only is that true, but here are the AV pairs. And the attribute value pairs are what define our network access. What VLAN do we go in? What access list do we get? Is a MACsec policy enabled, etc. We'll go into some of these in a little bit more detail as the class progresses.